Good morning and welcome. My name is Kimberly Holcomb. I'm the Director of Marketing here at Spirae, and I'm excited to welcome you to part 4 of the Net Zero webinar series that have been running for the past few weeks, titled Achieving Net Zero with Renewable Energy Microgrids. So welcome. We have a few presenters with us here today, which I will get to in just a minute. But before I do, let's do a quick recap of the series if you missed parts 1, 2, and 3. Okay, so to recap our series so far, why the emphasis on renewable energy microgrids for net zero? Net zero is a target that companies around the globe have set their sights on, and microgrids provide a really powerful, unique ability to make progress towards that in a way that is effective and that you can track that effectiveness. So the microgrid site services provide that monitor and control of your system at your facility, whether you're a commercial and industrial, provides you that system in real time that generates those gigabytes of operational data every day that allow you to both see where you are on your path to net zero today, and then also track that progress as you make your way towards net zero and make those strategic improvements and choices as you go forward. So because there is that limited storage capacity on the site controller, it seamlessly offloads that host of data that it's capturing each day and manages that data stream seamlessly by offloading that onto the cloud. So then if you look at the cloud side, the microgrid cloud services allow you that ability to look long term at your data management, at the analytics, the way that you're optimizing your system, and the way that you are communicating your achievement of net zero, whether it's to stakeholders or using external applications to really process that data and communicate that effectively. So they provide that really powerful digital infrastructure that's necessary if you are on the path and making your way towards net zero. Today, we're going to focus in on the renewables aspect of our series. So today's topic is all about renewables maximization. Nathan, if you want to go to the next slide, let's take a look at what we're going to be covering today. So we're going to look at the impact of maximizing renewables. What does that do today with the resources that you have available today? How can you make the most of those? And then how can you position yourself for the next strategic move that you want to take and that next step on your path to net zero? So we're going to look at that principle of renewables maximization in action using 5 different scenarios that are going to increase in complexity. So no matter where you are on your net zero journey and with the renewable resources that are available to you, there is an action that you can take and something that you can be doing to use those wisely and use those well and make the most use of them. So I'm excited for the topic today. I have 2 Spirae team members with me today. We have Nathan Howard, who is the Director of Solution Delivery. He's going to be leading you guys through each of these scenarios and facilitating that narrative. And then on the demonstration side, we have Don Wright here with us today, who's one of our senior application engineers. And he's going to be running Wave on the back end. So every demonstration that you see, that is Don, our wizard behind the curtain, running Wave for you guys today so that you can see each of those scenarios in action. All right, with that, Nathan, over to you.
Great, thank you, Kimberly. Excited to join the team for this webinar series and share a little bit with everyone about how to make best use of renewable assets that might be available as part of your microgrid system. So as a little bit of an overview, we've put together a representative microgrid system here with our Wave controller and paired it with an emulation of what the real world environment might look like. Some of you that participated in earlier webinar series may recognize this, but just a quick overview. We've set up a system here that's grid connected. We have a point of common coupling here with the grid. that we'll be able to leverage that utility interconnect. And for some of the later scenarios, we'll even show some island operations where we'll open that breaker and be operating completely on local resources. So the local resources we've set up for our system here are some conventional generation, some diesel generators that you might see for backup applications are present in the system. We have a primary load here, which is our main building or facility load that we're interested in, keeping the lights on. We've also added some sheddable or flexible loads here that the microgrid controller can take advantage of in certain scenarios to be able to further optimize the use of resources. We have some renewable energy assets in the form of photovoltaic systems here, as well as some battery energy storage over here. So we'll be using various combinations of these resources as we go through our different scenarios along the way today. So the scenarios that we'll be looking at here, we're kind of starting from the very kind of basic system, kind of looking at the role that a battery can play even before you start adding in actual renewable energy, and then building on that, adding in additional resources to show how, as you grow, as you have more capabilities available to you, you can increase the sophistication of your system and take advantage of additional value opportunities for your microgrid and for your system operations. So jumping right in, our first scenario here is going to be looking at the use of battery energy storage and information about when there might be a low carbon content in the grid power. So even before you have access to renewable energy resources within your own microgrid system, you can start taking advantage of this type of information to move towards net zero or low carbon, just by having awareness of that kind of energy mix that's on the system and the carbon content in that energy. So many utilities offer this type of information. There's also third parties. Here we can take a look at what that marginal operating emission rate information might look like. In this case, we're looking at Watt Time provides information for many parts of North America. So kind of looking at what that carbon content is, in this case per megawatt hour. It can both be instantaneous or 5-minute intervals, but it also is often available as a forecast. So this information can be used by a facility operator or even an automated system to look ahead, see when there's opportunities to put low carbon energy into a storage device, and to use that later on as part of your system. By doing so, you can reduce your carbon impact of your power system. So we'll go ahead and switch over to the demonstration system. We'll take a quick look at how that might be set up. So as you can see on the screen here, we've got our wave one-line system. For this scenario, we are just looking at the primary load is being supplied currently from the grid. So we can see that primary load there as Don zooms in, and that load flow there. So what we're going to do with this scenario is take a look at how we can use the scheduling capability in Wave and set up schedules to opportunistically charge our batteries when there's low carbon available. So we'll switch over to schedule control, and we'll go ahead and open the faceplate for that control, and we'll see a system that looks very similar to maybe your Outlook calendar. And Don's set up a number of schedules already today to show when, just in this example, there might have been low carbon opportunities. There's some opportunities in the future that we might be able to take advantage of. But for the presentation today, we'll pretend that maybe right now there's an opportunity they want to take advantage of, so we can modify an existing schedule to start earlier than we might have anticipated to take advantage of that. Again, this could be operator initiated. It could be something that is managed by a third-party application or other inputs into the system. The main capability that we're looking at here is that scheduled mode and the ability to time your system operations, whether it's charging a battery or leveraging other components in your microgrid to align with your needs. Okay, so once we've got that set up and saved, we'll see that show up in our schedule here as a blue kind of pending event. And then here in about a minute, we'll see that schedule start and it'll start charging the battery for us. And with that low energy carbon content from the grid, then we'll be able to charge up our battery. And at the end of that schedule, we'll be able to return the battery back to a standby state and be ready for either the next event or go back to our usual operation. For our next scenario, we're going to be looking at how we start adding in renewable energy into our system. So what we'll be looking at is meeting interconnection requirements that might be necessary to satisfy the utility that we're interfacing with, make sure that they're comfortable with the additional technology that we're adding in. Often utilities will want to make sure that these distributed energy resources are not disrupting grid operations, that there's not often a reverse power flow. Zero export is often a requirement that you'll see where they want to make sure that any excess energy that's being produced by your facility is not flowing back to the grid, creating capacity issues or operational issues or even safety issues for that grid operation. So the Wave controller can help manage the system within those constraints while still making best use of any available production from those renewable assets that you've invested in. So for this scenario, we're going to be kind of looking at that point of common coupling, that PCC. We'll be adding in those PV assets, and we'll be looking at how we can make best use of those. So we'll switch back to Don to take a look at what that system will look like. Great. All right, so once again, we've got that primary load for the system being fed from the grid. In this scenario, we're going to be looking at the export limiting control. So we'll go ahead and get that started. And then we'll take a look at the trend screen for this control in the Wave interface. And we can see some key limits that we've set up here. So the red line up at the top, that's actually at the zero active power limit. So that's our zero export requirement from the utility. We want to make sure that we're never in violation of that so we don't have any trouble with our utility. And to help us do that, we've set up a control preferred target, which is the teal line there, which is kind of got a nice safety margin below our hard limit, where we're going to be controlling the system below that. It gives us a little bit of room in case there's an overshoot or something unexpected happens. We can still maintain the system below that hard limit. And finally, at the bottom of the screen, we have our reference meters. This will be the point of common coupling and the active power flow there. So right now we're importing about 100 kW of power. So what Don's going to do is we're going to go ahead and use our emulator to ramp up the PV available in the system. So the sun's coming up and our PV system will start producing some power. And as that power becomes available, we'll see that we'll stop using the grid power. We'll use that locally produced energy to the extent possible to be able to meet our energy needs. So we can see that come up, stabilizing there, using that available power. And now as the sun continues to come up, more PV becomes available, our PV production may exceed the current load that we have. And so we'll see that as that available production comes up, we'll kind of start heading towards that limit. But again, because we want to make sure we're meeting those requirements from the utility, we're actually going to curtail the system to stay below that limit, the PV production in the system, so that we stay, a nice margin below that limit, and that we're, no danger of violating that. So we'll use as much as we can to meet our load, but we're also going to make sure that we're not violating that limit here. So we'll curtail that production. So obviously, curtailing our renewable energy production is not ideal. Where we can, we want to make best use of that. This whole presentation is about maximizing your renewables. So for the next scenario, we're going to take a look at those flexible loads that we have in the system. So these might be electric vehicle chargers, they might be electric water heaters, could be reverse osmosis system. We've seen that in literal island applications. So you can imagine these as kind of non-essential controllable loads that may not be time dependent in their operation. So we can leverage these as part of our control system to be able to take advantage of periods of time where we do have that excess generation available from our renewable assets. And instead of curtailing, we can turn these loads on instead and make best use of that available energy. So in this scenario, we'll switch back to our demonstration. And we're going to look at a little bit of a different control here. So in the previous example, we were looking at that net zero limit, but that if you maybe don't have that constraint or there's other things that you're looking at, you might want to use demand limit. So this is kind of the 180 flip of that, where as a facility operator, you might want to be using as little power as possible from the utility. You want to reduce your energy costs, your energy bill, and so we're going to take advantage of the demand limiting control. So we'll go ahead and get that started. And in this case, then now we'll be trying to reduce as much as possible that utility consumption of power from the utility. So Don, yeah, there we go. Starting the control. And we can see that here. So maybe if we go back to the one line. Great. Okay. So in this situation, we've got the primary load for our facility online being fed from the grid. We haven't added any PV generation yet with the emulator, but as that becomes available, we'll start ramping that up. And we'll see that as more and more renewable energy becomes available, we'll start closing the breakers to those controllable loads there, kind of just in the middle left of our one line. And we'll be either charging those electric vehicles or creating some hot water or whatever the case may be, where we're able to take advantage of that instead of curtailing our production. So we've set up with kind of some internal ramps that are configurable for the assets. So we want to make sure we're not adding large loads or taking sizable production offline suddenly. So we'll be have these kind of timers or ramps between when we're adding systems assets to the system. The other consideration is that Wave has the ability to understand when assets are either in a local or remote control state, where if the asset needs to be maybe manually operated from the faceplate or as part of in a maintenance state, to be able to not be part of the typical operation. So in that situation, Wave won't take advantage of those assets. It'll still show them on the one line. It will still monitor them, but it won't use those. It looks like maybe those loads are still in that state in the emulator, so Wave won't be bringing those online for us today. Okay, for our next scenario, we want to look at how we can take advantage of renewable energy assets during island operations. So one of the key benefits that a microgrid can offer to a facility is that resiliency component, being able to operate when the grid is not available, either as part of a planned transition or an unexpected resiliency event, being able to make full use of available assets in those times to keep your lights on, your system up and running for as long as possible in those scenarios is a key value that microgrids can offer to a facility. So in this scenario, we're going to be looking at that conventional generation resources. Again, these could be kind of thought of as your typical diesel backup generators that you might have, and also supplementing those with those renewable energy assets that we've invested in, and making sure that to the extent possible, we're able to offset the consumption, the fuel consumption for those conventional generation assets with our renewable energy assets, while still maintaining a stable system during island operation, and making sure that we can run that system for as long as possible when we don't know how long the grid may not be available to us. So in this scenario, we'll take a look at that intentional island capability that Wave can bring to your microgrid. It allows you to do planned island transitions, do smooth transitions when you do have information of when there might be instability in the grid, or it's just in your best interest to be able to operate on your own in the weak grid scenario. To show that capability. And then once we're islanded, we'll be taking advantage of those renewable energy as it becomes available and backing off our conventional generation. So Don, maybe we can switch over and take a look at that if you're ready. Excellent, thank you. Okay, so right now, we're still in our grid connected state. We have made those conventional generation assets available. So they've switched from that local mode to remote. We haven't started them yet because we're grid connected. There's no reason for them to be online. We've backed our renewable profile back to 0 for the time being, just to show more clearly how the system's reacting to the changes that we're going to introduce. So again, that primary load is online, being fed by the grid. And so now we're going to go to our system control, and we're going to use what's called the PQ balance control. So in preparation for island, we're going to make sure the island control is running and ready for us to make that transition. What that'll do, it will basically bring on those conventional generation resources. So when we do make the transition, we have a frequency and voltage master that'll maintain a stable island for us. And so when we start that PQ balance, that's going to look at the active and reactive power flow across the PCC. So we'll go ahead and initiate that action now. And we'll start ramping up that conventional generation to meet the load of the system, reducing our consumption from the grid. And once that consumption from the grid is 0, then we'll open that grid breaker up and we'll be operating in an island state. So there you go. You can see, brought up the generators, open the breakers. So now we're operating in an island mode. So now as renewable energy becomes available, So right now we're running purely on conventional generation, but as renewable energy becomes available, we'll ramp up those PV profiles, start producing some energy from our PV inverters. Those will start feeding the load. And as a preferred resource, the lowest carbon resource available to us, we'll start backing off the conventional generation as that renewable energy ramps up. And if sufficient renewable energy is available, we'll even shut down one of the excess gens. Now, in this scenario, we still need to have a resource online that's going to be our frequency and voltage master. So we'll be keeping one of those generators online for now, since PV inverters aren't going to be able to provide that service for us. But we will make best use of that within the operational constraints of the generators. So we'll want to make sure that we're maintaining the minimum gen loading, operating the generator at its most efficient point, so that even though it is a conventional resource, it's at its lowest carbon output possible, while allowing us to make best use of our renewables. So there we see the second gen's offline. We're feeding the load primarily from the PV, but maintaining that stable island. So for kind of our natural next step here for us is going to be looking at, well, how do I kind of combine all the pieces together? So for our last scenario here, we're going to be looking at completely replacing the conventional generation with renewables. So in order to do that, we need something that can be that frequency and voltage master for our system. And many battery energy storage systems that have that grid forming capability are going to be able to provide that service for us. So what that'll allow us to do is then back off the conventional generation completely and run on batteries plus PV. So what we're going to be doing there is reintroducing those batteries, making them available to the system to control. And then once the system recognizes they're available and are sufficiently charged for our purposes, then it will use those as its preferred resource and switch over to use the batteries and back off and turn off the conventional generation. So let's take a look at what we can see with the wave controller in that for this scenario. Okay. So kind of back where we were, we've got one generator online providing that frequency and voltage master service. We have our PV online. We're using as much as we can. So now we'll go ahead and switch the battery over to be remotely controllable and available to the Wave microgrid controller. And as we see those become available, we'll see Wave brings them online, closes the breaker, and starts pulling power from them to meet the needs of the system. And when those now are available, we see that it's backed off the conventional generation, shut that down. So now we're operating in a purely battery and renewable operation to meet our loads. And as long as that there's enough renewable generation available and we have sufficient charge in our battery, we'll be able to operate here as long as we can. If we're in an island state for long enough and there's a cloud or the sun goes down and that PV no longer is available, then we'll bring back in that conventional generation. Again, the main priority is to keep our operations going as long as possible until the grid is restored. So that brings us to kind of the conclusion of our scenarios, where we've been able to show kind of even from a very basic system with just some energy storage added to your facility, you can already start to realize lower carbon opportunities and moving towards that net zero. As you start adding in renewable assets, you'll be able to meet those interconnect requirements, be able to meet the requirements from your utility to operate those assets, expand those assets in the future. And when you start bringing in additional resources that have flexibility to them, you can make use of those loads, charge those electric cars from renewables, charge your battery from excess renewable energy, and make use of your low carbon resources. And then even in islanded scenarios, you can continue to use your renewable energy assets and even go completely renewable only when the conditions are right for that. So with that, I'll hand it back over to Kimberly to wrap us up.
Thank you, Nathan. And Dawn, thank you for showing us those just actionable steps you can take really at any point on wherever you have whatever resources you have available that are renewables to you, whether that's just renewable content from the grid and making decisions on how to use that wisely, or those on-site local resources as well. I hope through all of this, it's been really clear to see that renewables are a key resource on your path to net zero and have the ability to grow with you as you move towards that target. However, as you've seen in this series, if you've tuned into any of our previous sessions, I hope that you'll tune into future ones as well. Renewables is one of those value areas or those kind of levers that you can use to really create substantial value as you're pursuing that end goal of net zero. So you can see there on the diagram on the right, there's different changes and decisions you can make within your system and your energy system, providing it to be more efficient, to manage demand better, to incorporate more renewables, to have the optionality for resilience that all help contribute to that overall target of net zero. As you make these decisions and improvements and take those next steps that Nathan detailed, it's so important to have a common same digital infrastructure that you can leverage to capture each of those increasing benefits that I just talked about and that Nathan and Don demonstrated, and really help that infrastructure would also help you reduce those barriers to your net zero transition, provides that seamless foundation and that powerful capability to activate each of those values and to eventually reach that target of net zero. To know whether you are on target or off target or how close you are to that end goal, highly recommend going back and watching webinar number 2 or contacting Spirae to know more about our wave analytics service. It can really further enhance that transition to renewables and accelerate your path to net zero by that visibility into the data that you have within your system and just the ability to make those smart goals and strategic decisions. Talking about what's coming next, a little sneak peek for you. We are going to be focused on market participation in webinar number 5. So in a few weeks, we're going to be bringing on a partner as well and talking about market participation and how you can unlock additional values with those renewable assets that we've talked about today, either that are already available within your local system or that you're looking at incorporating on site. So I hope you'll tune in again and come join us for webinar number 5 and continue watching along if you're watching this series on demand. Thank you for joining our Spirae team here again on this lovely Wednesday. If you can go to the last slide, Nathan, there's a contact there. If you have any questions or want to continue this discussion about maximizing renewables with our team, feel free to reach out to our team at Spirae, and we'd be happy to continue the conversation with you.